Hey students, welcome back, welcome again. So we are back in action with coordination compounds, complex compounds, class 12th, the backbone of modern inorganic chemistry or bioinorganic chemistry, most important chapter if you are looking to crack any competitive exam or very important for your board exam. For board exams, you can expect about 4 marks from this chapter, and in competition you can expect at least 1 or 2 query from this chapter. Now, what is the basic strategy to study this chapter? It is a big chapter as we all know, but a logical one. The interesting part is, it is a logical chapter. The basic strategy goes like this. We have the basics and we have the pillar of this chapter, the pillars. Now, the basics include our introduction. Next we have is what we have IUPAC naming and isomerism. So the basics include 3I, introduction, IUPAC and isomerism. Now let's talk about the pillars. For pillars we have CFT and VBT. Now if you do not have a good timetable of study and you want to take risk, then study VBT from here and IUPAC from here. And in isomerism we have 2 varieties. There is a structural one and the stereo one. So I suppose you must look for the structural one. So it's a 60-40 chance, but you will survive in your board exam VBT, IUPAC and structural isomerism. But if you have competitive approach, we will study one by one each of them. And as far as board exams are concerned, the IUPAC naming is the most prominent question in it. So let us begin complex compounds, coordination compounds. Now the name suggests, oh shit, that was my hanky. This one is for cleaning. Now, as the name suggests, coordination or complex compounds. So most of the students think it is something complex, some structure that is highly complex. And look here, if I ask any student which of the following is complex, he will say, sir, this looks complex, sir, this looks complex, this also looks complex, these and these, they look simple in structure. Lithium aluminum hydride, it is not a complex, it is not a complex. Now, the correct solution, the correct answer to this problem is, sir, this is not a complex, not a complex, not a complex, and these two are our complex. So how will we judge which of the given compounds or which of the following compound is a complex? How will we name them, and we will study their properties. Now first of all, there is a term called addition compounds. Addition compounds is basically the mother of all compounds. When 2 salts, 2 or more than 2 salts combine with each other and form a crystal, then we call them addition compounds. These addition compounds are of 2 types. One is double salt and the other is, this is called complex salt. Now, as far as double salt is concerned, sir, it will give all the identities present in it. It will give all the identities in it. Now, if you consider this is what? Carnallite. It is an ore of magnesium, a chloride ore of magnesium, and if we form aqueous solution or any particular solution of this, it will give us what? Potassium ion, magnesium ion and chloride ion. This is the expected ions, potassium, magnesium, chloride. So whenever our salt gives us what? All the identities present in it, then we say it is a double salt. And by definition, double salt means a salt formed by combination of 1 or more, 2 or more simple salts. Look here, KCl is a simple salt, MgCl2 is a simple salt. Their combination gives rise to carnallite, which gives all the identities. Next we have is alum. Alum also give all the identities. So it gives potassium, sulfate, and aluminium, and it gives positive test for all the 3 here and all the 3 here. Same goes for this more salt. It also gives positive test for ammonium, sulfate and iron, and it will not mask all its identities. It will show us what it has. Now moving on to the complex salt. These are the salt which do not reveal their identity. These will not reveal their identity. They will not give all the ions present in them. They will do not respond to all the ions if we test them. These are called complex. This is the term complex for that. And these are included in our chapter. The chapter will be coordination compounds or complex compounds. So I think you have a good idea about what complexes are. They will not reveal all the identities. Now let us consider this lithium aluminum hydride, and if you test the hydride ion in it, it will give a negative test. It will not show hydride ion. So this is a complex salt. Now how to judge them? So in order to judge them, you need to study them thoroughly. So we will begin with the basic terminology. You need to take a screenshot of that so that we can just move on. So let us move on to the terminology. Just a second, and I will clean this up. Now, what is the terminology involved in this? Or I can say, how does a complex look? Now, if you look at a complex, it will be like this. There will be 3 probabilities. I will show you them, all the 3. Look here. A, B, C, E, now if you look here, the species present on the extreme left outside this bracket, that will be our cation, and any species present to the extreme right of the square bracket, that will be our anion, or it can be water molecule in the form of water of crystallization. So left side cation, right side anion. Now this square bracket, this particular bracket, it is our VIP lounge, it is VIP area, because the ions in it will not ionize. So it does not ionize. Now what we have in it, or what we call this VIP area, the name of this VIP area, this square bracketed area, is coordination sphere. Coordination sphere, or we call it coordination entity. So this is coordination sphere, this is the cation, this is the anion. Now the first species, the first element present in this coordination sphere is E, in this case it is C, and in this case it is B. So C is what? It will be our central atom, it will be our metal, it will be central metal, and this dump, anything after metal, this dump or this garbage, this dump will be what? It will be called ligands. So it is the basic terminology. To the left is cation, to the right is anion or water of crystallization, and the square bracketed area, that is coordination sphere or coordination entity. Next is the first member, the first element in the square bracket is our central metal, and the dump, the rest is what? Ligands. Now let us discuss this coordination sphere. If you look here, now let us consider the example first. If we have this K4 FeCN6, if you look closely, I think you may get this. This is potassium. It will be our cation. The first member in the square bracket, that is our metal, and these 6 will be, the rest will be what? Ligands. As simple as that. The basic terminology. The coordination sphere starts from here to here. So the coordination pair contains 6 CN and 1 Fe. Now, if you look at the coordination pair, it is like that: Fe with a CN, with a CN, with a CN, 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 and CN. So it looks like this iron surrounded by 6 cyanides, 6 CN groups. Now, the iron is particularly the acceptor in this case. Iron is what? The acceptor. Acceptor of what? Electrons. Electrons are the basic currency of bonding. So, cyanide, the CN will tends to give its electron to iron. Basically, lone pair of electron to iron. So, cyanide turns out to be our donor. So, in the coordination pair, there is a acceptor-donor interaction in which the ligands donate their electrons to the central metal, that is iron, and iron will be our acceptor. And the bond formed between them is coordination bond. In 90% of the cases, it is a dative bond. Hence, the name of the chapter comes coordination chemistry or coordination compounds. Now, one more term I would like to discuss before ending this video is a term used frequently in this chapter, that is homoleptic and heteroleptic complex. What is homoleptic complex? What is heteroleptic complex? Now, if you look at any complex, let me consider this K3FeCN6. You are looking at 6 cyanide, which is the basic ligand our. Then this will be homoleptic because it has same type of ligands. But if you look here, I have CONH3 with Cl3. This is a heteroleptic complex because ligands are different. 3 chloride, 3 NH3. Therefore, it will be heteroleptic. Same type of ligand, homo, different, hetero. So, I hope you love it. So, we will catch up you in the next video and we will discuss its naming, AUTOPSY, nomenclature. So, till then, take a good, nice screenshot and write it down thoroughly so that it does not flush from your memory. So, get back to work.